Hey there, vloggers. Here we go. Time to work on some more probability. We are going to be looking at expectation, otherwise known as expected value of a game today, and we're going to be looking at the idea of fair game as well. So let's get started on that. So let's say I gave you money every school day. So on Monday, I gave you $1. On Tuesday, I gave you $2. Wednesday, I gave you $3. Thursday, $4. And Friday, I gave you $5. I would be a very broke teacher if I did that. So, anyway, if someone asked you how much money you got each day, what would you tell them? Okay, what would you tell them? How much money do you get? You would probably tell them the mean or the average, right? So you would probably say, well, I get 1, and then I get 2, and then I get 3, and I get 4, and I get 5, but that's over the course of 5 days. So on average, if I add those together, I get 15, divide that by 5 days. On average, I'm getting $3 a day, right? You get an average of $3 a day. Well, we can do the same thing for games of chance. If I got $1 for each dot on a die, so if I was rolling dice, but I'm just got 1, so we call that a die. If I'm rolling a die, and I got $1 for each dot that came up on the die, what would be the average amount of money I could get? Okay, so I could get $1, or I could get $2, or I could get $3, or $4, or $5, or $6, because the most number of dots on a side of a die is 6. So on average, what's the average amount of money I would get from a single roll of the die? So I don't know what it's going to land on, but if you think about it, if we did this a whole bunch of times, what would you end up being the average amount of money you would end up with? Okay, so if you roll the die over and over and over again, you're bound to get about the same number of 1s as 6s, about the same number of 2s as 3s, etc. So we can just say, well, the average would just be, well, if I add those all up and divide by 6, because there's 6 different possible things that could happen. Okay, so if we add that all together, we would get 21 out of 6, which is equal to 3.5. So on average, the amount of money you could get from rolling a single die would be $3.50 if you were being paid $1 for each dot on the die. And you might say, wait a minute, but there's no side of the die that has 3.5 dots. All right, that's because we had to average out these numbers, and it ended up not coming out to a whole number, and that's fine. Okay, so in this case, we don't get a discrete answer really from these discrete numbers we put in. We had a certain number of dots, but that's fine. We're just taking the average amount of money we would get. Imagining if we did this, we rolled the die over and 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 over again, figured out how much money we got and divided by how many times we rolled. That would be our average. So I would expect to get about $3.50 each time I rolled the die. So we call this the expected value. Okay, so there is a formula for this. There's a notation for this, and we're going to put this notation into our notes. So I'm going to bring my notebook up, and this is what we're going to put into our notes. Expectation or expected value. It has a formula, and so the notation looks like this. E of capital letter X, okay, remember X is from our probability distribution. That is the event. So the expected value of an event, say rolling a die. It also can be written as this Greek letter, whose name I forget at the moment. Look it up. Tell me how you spell it. Send it to me in an email. Maybe I'll give you some extra credit. All right, is equal to, actually that's a really good idea. Okay, I'll give you 1 point extra credit on your math space assignment if you can tell me how to pronounce this symbol, because I don't remember. So somebody look it up and send it to me. You have to write it out phonetically in English. Okay, so anyway, here's the formula. It's going to be the sum of all the values of x when you multiply x times its probability. So remember last week we were setting up probability distribution tables. So the X is the number on the top of the table, your X values, of course, X values, and the probability of each of those were basically your Y values, the other part of the table. If you multiply them together, you're going to get the expected value. Okay, so let's look at our die problem. Okay, so think about it. If you're rolling a die, what are all the things that you could get? So we're going to write out our probability distribution. So the different values we could get a 1, or a 2, or a 3, or a 4, or a 5, or we could get a 6. Okay? And what's the chance of getting each of those? So if it's a fair die, in other words, it's not weighted heavily on one side or something, we have a 1 out of 6 chance of getting each outcome. 1 out of 6, 1 out of 6. The probability is the same for each side of the die. Okay, so now our notations here says that we're going to add up X times its probability, and that should give us our expected value. So remember, we did the expected value before, and we said that our expected value was 3.5. Okay, so if we're getting $1 for each dot on the die, what is our expected value? Well, according to this formula, we should be able to just multiply these together and add them together. So let's see what happens. So our E of X is going to be equal to 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6. I'm running out of room. Plus 6 times 1/6. Sorry, that got right into the middle there. Oops. Okay, so if we simplify that, I get 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. Yikes. All right, now, nice thing, they all have a common denominator. So all I have to do is add my numerators. 1 plus 2 is 3, plus another 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. 21 over 6, hey, it worked out. That gives me my expected value of 3.5, or $3.50, if I was getting paid $1 for each dot on the die. So there is our formula for expectation or expected value. Okay, so you are going to be doing some problems in MathSpace that not only ask you to find the expected value, but they're also going to ask you if something is a fair game. So I'm going to stop this video and I'm going to go over to MathSpace and I'm going to make a screencast video of me doing one of the problems in MathSpace. Because they get a little bit different over there than what IB actually expects you to do. This is what IB wants you to be able to do, find the expected value, but we're also going to look at something called fair game. Is something a fair game? So I'm going to take a break on this video, and the next video will take place in MathSpace with the problems that you actually have to do there. See you soon.